Alright guys, for these three examples, this is kind of an extension of now looking at some little word problems and learning how to translate these sentences into equations. So in this case, example G, the sum of a number and its square is 42. Find the number. So we have some keywords. The sum of a number, so a number here, a number, so a number I'm going to define as x. If my number is x, then its square, so its square is going to be basically x squared. It's the number squared. So I can define those terms that way. And then it says the sum of these two things is means equals 42. So in this example, I can translate this to x plus x squared. So again, the sum of a number and its square is 42. Once I've translated the words into terms, then I can start to attack the actual equation. So this is a quadratic because of the square. Now this is not in standard form. So my first goal would be to write this in standard form so I can identify the A, B, and C values here. So in this case, I got to move this 42 to the left side. So I can subtract 42 on both sides. And then in doing so, I do get my 0 here on the right side. If you look here on the left, it's kind of jumbled up, but I'm going to put it in standard form with the largest term first. So I'll put x squared plus x minus 42, and then I have equals 0. That's how these are all not like terms. I just write them side by side. Now I have an a B, and a C. So now to find the number, I just got to solve the quadratic. And I can do that by factoring and then finding the solutions or the roots. So in this case, I'm going to go to an x factor first here on the side, negative 42, and then here my b number is 1. And 42 is 6 times 7, where the 6 will be negative, so that'll work there. So at that point, I can write x squared, and again, in place of writing this plus x, this middle term, I can now take this middle term here and write it as minus 6x plus 7x. And then I have minus 42 here on the back. So again, notice how the only point of the x factor is to find these side values, which gives us a way to split this middle term now into two equivalent values. Now I'm going to group. So first 2, second 2. Here I take out a 6. So I have 6x minus 6. Sorry guys, my brain went too fast. There's not a 6. I apologize. It's a little late. An x is what I meant to say. So I take out an x minus 6. And again, we know this will have to be the same on the other side. But for this to work, divided by a 7. So I get my factors of 6x minus 6, x plus 7, and that's going to equal to 0. So again, in this question, I want to find the number. So I want to solve for x, because x is my number in this case. So if I solve this equation, I can set each factor equal to 0. So x minus 6 equals 0, or x plus 7 equals 0. I can find quickly that if I add 6 to both sides here, I get x equals 6. Here I can subtract 7 and find that x equals negative 7. Now in this case, if it says to find the number, these both work. There's no restriction to what the number can be. So if you want to verify, just check. If I take 6 plus 6 squared is 6 plus 36. That's 42. That works. If I take negative 7, then if you want to see that work here, I can say negative 7 plus negative 7 squared. Would that be 42? If I check it, it's negative 7, and this becomes a positive 49, which will give me 42. So in this example, both solutions work, so I can use either of them. Guys, with that, examples H and I, look at them carefully. Example H has some restriction on what the number can be, so you're limited there, potentially. And also, in example I, you're talking about the side lengths of a shape, so you shouldn't have any negative values in this instance. Give it a shot, guys.